This is the second video where we're going to look at prefixes in your science GCSE. A prefix can be placed at the beginning of a word to signify a certain order of magnitude. You may be aware that you can place centi, as in centimetre, in front of the unit to make centimetres, and that would be 100th of a metre. On the screen now are some reasons why we may need to use prefixes in science. So you can see that an animal cell has a diameter of around 15 micrometres. If we were to write this as a decimal, that would be 0.000015 metres. So you can see it's much easier to write 15 micrometres. Some other things that you might be aware of are that red light has a wavelength of around 680 nanometres. Again, if we were to try and write this as a word, we'd be saying 0.0000068 metres. And also an average garden pea has a diameter of about 7.5 millimetres. Again, we'd have to put lots of zeros at the end of this, so 0.0075 metres. So hopefully you can see the importance of using prefixes to help simplify the numbers we use in science. This is a table showing all the prefixes you need to use in physics. Today we're going to mainly focus on the bottom area and look in particular at centi, milli, micro and nano. I've highlighted the ones that we're going to focus on. So you can see that centimetres are 100th of a metre, so times 10 to the minus 2, or 0.01 metres, and you use the lowercase c to represent centi. A millimetre has a lowercase m, and it's times 10 to the minus 3, and it's 0.001 metres. Micrometre has the Greek symbol mu, it's times 10 to the minus 6, and is 0.000001 metres. And nanometers come next. They're times 10 to the minus 9, and they're essentially a billionth of a metre, so 0.00000001 metres. If you look at the table, you can see that the standard form variations all go up in powers of 3, apart from one example, which is a centimetre, where it's times 10 to the minus 2. It's the only prefix that breaks that trend. So in terms of simple ways that we can convert from small prefixes, what we need to do here is for all of them, we're going to divide by the value of the prefix. So if you want to convert centimetres into metres, we're going to divide by 100. If you want to convert millimetres into metres, we're going to divide by 1,000. To get micrometres into metres, we divide by 1,000,000. And to get nanometres into metres, we divide by 1,000,000,000. You may want to make a note of those conversions now. So now we're going to work through some worked examples. You may be able to do this on a sheet that's been provided for you, but if not, you can just do it on some paper or in your own notes. So the first question is, the student measures their favourite pen. They found out it is 13.94 centimetres. I want you to convert that length into metres. So here we should remember that there are 100 centimetres in 1 metre. So we want to convert that into metres by doing the 13.94 over 100, and that will give us our answer in metres, with the answer being 0.1394 metres. Remember, you can use a calculator for all of these calculations. The next question says a dung beetle has a length of 30 millimetres, and you want to convert this length into metres. So 30 millimetres, remember that there are 1,000 millimetres in a metre. So in this case, we're going to do the 30 over 1,000, and then we'll put that into a calculator to get an answer. That's going to equal 0.03 metres. Looking at our next few worked examples then, it says a parasite cell has a diameter of 7 micrometres. Once you convert that into metres, so with the 7 micrometres, remember there's 1,000,000 micrometres in a metre. So we're going to do 7 over 1,000,000. And we can put that into a calculator to get the answer that we need there. Now, my calculator, that's left the answer in standard form, so I'm just going to use standard form here. So that will be 7 times 10 to the negative 6 metres. Okay, if I was to put that as a decimal, it would be equal to 0.0000007 metres. The final question, question 4, says violet light has a wavelength of 380 nanometres, we'll just convert that value into meters. So again, you can do the 380. We're going to divide it by 1 billion this time. And then we put the number into a calculator to find the answer. This gives us an answer. I'm going to leave it in standard form again, which is 3.8 times 10 to minus 7 meters. If we were to write this as a decimal, we would get the answer to be 0.12345 and then it would be 38 meters there. So hopefully you managed to follow that through and you've marked your work now and you know you're happy with them. We're just going to move on to the final slide before I hand over to you to complete the rest of the work yourselves. So hopefully you have been provided with this worksheet. What I'd like you to do now is I'd like you to work through the questions, starting off with a table, if you've done the work examples together, and then once that's been completed, you can mark your work using the answers. Thank you for listening. I hope you found this useful. I look forward to working with you again in the future. Thank you and goodbye.